Hello everyone, can you hear me? Hello. Hello everyone, can you hear me? Okay. Assalamu alaikum. Today we will be talking about machine learning. First of all, I would like to apologize for everyone for the technical issue we are facing. It's not enough that the entire world is going through this coronavirus pandemic. Also, today in Dubai, it's the second day on a row where we have not only rain, but it's also snowing. If you ever told me in March I'll be seeing actual snow in Dubai, I would never believe you. I send all my empathy and my wishes and my prayers for all of you. I really, really hope that you are staying at home, acting responsibly, not for you only, but for the society, for the world, and for everyone we love around us. Let's be part of the solution by simply staying at home and not spread this virus while the entire world figure out the solution. Today, my session will be about machine learning. And the reason I created this session is because I kept hearing the word machine learning, big data, data analysis. And as a software engineer who only focuses on Android development, I never understood what those big words mean. And I decided to go ahead and do some research and understand machine learning myself. After doing a lot of research, let me introduce myself. My name is Rayan Al Zahab. I'm a Google developer expert in G Suite, and I founded the first Google developer group in Lebanon. Now I am the GDG lead and the Women Tech Maker ambassador in Dubai and both in Lebanon. I work as a senior digital consultant at McKinsey. So when I decided to understand what machine learning is, what big data means, I went and I did a lot of research. And the easiest sentence that I was able to find to explain what machine learning is was processing data to identify patterns in order to analyze it on a new data and come up with predictions. That's not simple, right? So let's together try to understand this complicated sentence. And let's shop it. In order to understand machine learning, let's go back and remember human learning, how we as a human learn. Let's go back to the years where you were in school and they tried to teach you how to do simple math. One apple plus another apple means two apples, right? This is how all of us learned math. And in order to understand the machine learning, we need to understand how a human learns, because it's exactly the same way. Now you will see on all over social media those riddles where you got some lines with answers and they ask you to come up with a solution. So I'm going to give you a few minutes. Look at this slide and tell me what is the answer for the last row. Go ahead. Remember, Omran promised you guys some prizes at the end of every week. So maybe this will get you some points. Who's the first person to know the correct answer? Okay, I can see some answers coming in the chat. Minus 20, 100, 110. I'm gonna pause to answer on one question on the chat about the language. So every session we will commit to present it in a specific language. We would like to cater for everyone who understands in all the languages. So this session was announced to be in English. We will repeat this session later in Arabic. And if you don't understand English clearly, please stay tuned and attend the Arabic one. هعيد اللي قلته بالعربي. كل سيشن نحن اخترنا نقدمها بلغة معينة لحتى نقدر نوصل لكل الأشخاص يلي بيحكوا بكل اللغات. هيدي السيشن تم الإعلان عنها باللغة الإنجليزية، لهيك نحن عم نقدمها باللغة الإنجليزية. حنحاول لاحقا إنه نعيد هيدي السيشن باللغة العربية للأشخاص يلي مهتمة بالسيشن. Okay, let's see what the answer is. First of all, how did you analyze to come up with this answer? You took the 3 first lines where you know what the answer is, and this is what we call your data. So you said 3 apples equals 90 means 1 apple equals 30. 1 red apple plus 2 green apples equals 30 means 1 green apple equals 50, which means the last row is equal 80. What you didn't notice is we have 2 green apples, not only 1. So let's go back again and remember what is how we usually learn. Machine learning is processing data to identify patterns. So what we did, we took this problem, we chopped it. This is our data where we know the actual response. We analyzed it to come up with a pattern. We use that pattern on the unknown, on a totally new line, which we don't know the answer for, and we come up with an actual prediction. So how humans learn is we identify a pattern in equations that we know the answer for. We use what we learned on a new data that is completely unknown for us to come up with the new answers. And this is exactly how the machine learns. Now, if I ask you to use exactly the same logic to give me the response for this riddle, 6 plus 4 equal what? 210. And I ask you, 15 plus 3, what is the answer now? Take a few seconds and tell me, do you have enough information to come up with the answer? Probably not. What about now? Now that I gave you extra data, do you think you can come up with a solution? Go ahead and think about it. Let's see who will give me the right answer. Okay, I'll give you a few more seconds. And the answer is, most of you are correct. The answer is 1218. But there's something wrong, right? How come 10 plus 6 equals 1218 and 15 plus 3 equals 1218? Yes, the equation that we came up with applies for most of our data, but it doesn't apply for the last line. And this is where we talk about the probability. What I want you to actually think about is, I need you to identify a pattern that will work on the majority of your data. It doesn't have to always work on all of your data, and come up with a pattern that works for the biggest amount of this data, and then apply it on the unknown to come up with the prediction. In our data, especially when using big data, not all of them are consistent. Therefore, we might find some wrong data, we might find data that we need to remove. And this is why we focus on the pattern that work on the biggest probability. I can see many people asking how. This is how. So today, IoT is everywhere. Your TV, your refrigerators, your computer, and even your Google Assistant are all online and connected, right? All of those devices are sending and collecting a lot of data. Therefore, we need to actually leverage it to be able to serve our customers and our users better. It doesn't make any sense for all of this data that exists in the world to be sitting there and no one actually leveraging it. And this is where the machine learning became a reality, using all of this stored data. The machine today know about you more than you know about yourself. They know what you like, what you hate, what you want, and they can suggest to you things better than your own best friends. How many times you got suggestions on Netflix or on a music streaming application that really, really worked for you better than any other friend who suggested for you? So why do we analyze this data? We analyze it to understand and target our clients better. We analyze it for better financial trading, especially in times like today, where the market is changing drastically. It is using big data that we can understand the patterns, that we understood how to actually take this huge curve in the coronavirus pandemic and study what happened in China, what happened in Italy, and be able to identify that using this data that we are collecting on all the patients, we know what will happen next, and we can avoid it, and we can act before we hit the crisis. And finally, we can do a lot of optimization. We optimize in business processes, in athletic performance. So many of those athletics in the Olympics, they track their performance in order to identify some patterns. So they can tell when they sleep over 8 hours how it affects their performance in jogging. And they can change the way they train accordingly. Public health, device performances. One of the biggest companies decided to do analysis on how their refrigerators work. And they were able to monitor 7.5 million refrigerators that they actually produced. From analyzing all of this data, they were able to identify exactly when one piece will break. And they were able to have a preventive maintenance for all their refrigerators before they actually went down, serving their clients better and gaining more profit. So let's take this example. This is a mechanical engineer, doesn't know programming. His parents has a cucumber fields farm, and they spend most of their days only sorting the types of the cucumber. And they have multiple types. So he decided to help and support his parents by actually creating this device that can automatically sort the cucumber according to the length, to the curve, and all the characteristics. So who is using machine learning? Machine learning is in your everyday life. Obviously, Google is using it. When you do your Google search, when you write your emails, I think Abdulaziz already went through how machine learning is embedded in our emails. Facebook, when you get the suggestion about the people you may know. Amazon, every time you fill your cart, every time you browse items, they are using machine learning to know how to present your new product in a different way, when exactly, and how. Netflix and YouTube to understand your taste and suggest you new music, new series, and new movies. One very concrete example, which is one of my favorite examples, is how Macy's and Walmart use it. So in Walmart, they have a digital price tags, where the price tags actually changes on daily basis, based on the user's appetite, the user needs, and everything. This helped them get a 15% increase in revenue, which generates in millions of dollars. And finally, our favorite example, the self-driving cars. It is only a reality today because of machine learning and the big data. So let's together try to understand how machine learning can tell us what kind of music do we like, and how today's Spotify, Netflix, and all of those streaming apps can suggest to us a kind of music that we might actually like. So in order to understand your taste, this is how the data is analyzed. We take one song and we divide it into two categories: intensity and tempo. And we ask our volunteer to listen to music and just click like or dislike after every song. And we classify every song by its intensity and in tempo. Every circle in this graph represents one song. So the red circles are very low in intensity and at different tempo. We noticed that our volunteer always hit dislike when the intensity of the song is very low, but she always hit like when the intensity is high. So now, if we go ahead and we ask you, if I bring her a very new song that she never heard before, and that song is gonna be under the orange circle, will she likes it or hate it? So what do you think? If I give her a new song and this song follows under the orange circle, will she like it or hate it? What about the purple circle? Will she like it or hate it? Ahmad Shukri has the right answer. For the orange circle, we don't really know. We don't have enough data to draw exactly where the line where she hates it or like it. But for the purple circle, it's very obvious. She will definitely hate it, right? So this is how actually machine learning works. We take a lot of data, we classify it into multiple categories, and then we draw this line that will help us make decisions about what people will like or hate. Let's take another example. Self-driving cars. How self-driving cars actually happen today is they took so many volunteers who studied PhD, machine learning, big data, and they asked them to drive in cars with many sensors. And they drove hundreds of hours those cars on different roads, in the desert, on slopes, in a very smooth road, and other. And they started testing the speed with the category of the road. So they say, I'm going to divide the road into how bumpy it is and how slope it is. And then I'm going to monitor the speed of the car. And they started putting those circles that identify the speed of the car. And using that, they were able to predict when the driver should go faster and when the driver should go slower. And this is how today the self-driving car make decisions based on all this collected data from those drivers that drove for hours and hours to collect those decisions for us. They draw those mini circles, and then they draw something that we call the decision line. So everything under that line, they should always slow. Everything above it, according to the condition, they should go faster. And this is today how the self-driving cars make decisions while driving about their speed. For the sake of this example, we simplified it very, very much into taking only two categories just to showcase how the decision making and how the big data is enough to actually help us predict new decisions based on unknown data. This is my session. I hope you enjoyed it. And please stay in contact. I'm gonna stay with you for 5 minutes or 8 minutes exactly, and I'm gonna take your questions. How do we know? How do we know how much data we need? So every case is very different, and every scenario is going to be very different. As for the slides, all of those sessions will be recorded and will be posted on the channel. In addition, we will add some description with the slides. One of the best courses for me, at least for machine learning, is the existing one on Coursera that is developed by Google. It is actually developed by the people who worked on the self-driving cars. Isn't it against the privacy of the customers? Most of the application today that we download and use, we sign when clicking yes, I agree on those privacy terms. Does every software engineer need to know about machine learning? I don't believe that, but I do believe that machine learning is the future. So if you want to survive the new revolution, I recommend that you learn about machine learning. What's the difference between machine learning and deep learning? So this is an amazing question. You see in my example when, let's take the music, for example. When I said that I'm going to divide every song into intensity and tempo, I told my algorithm that those are the two categories I need to actually monitor. In deep learning, I don't set the category myself. I let it for the actual machine to identify what are the categories and then do the analysis based on the self-identified patterns and categories. Even if you're taking machine learning at university, it is very helpful to go through the Coursera machine learning course. I believe it's very practical and it has a lot of exercises you can play with. You will have an advantage that you already know how to do it. So it's an extra exercise for you. There is no such thing as too much learning. To start machine learning, you need to know a little bit of Python. You need to be comfortable with it. You need to be comfortable with algebra, base analysis. What are the hardware parts needed for machine learning? If you leverage the tools and the platforms that exist today, like TensorFlow, you might not need anything. Any simple computer is enough. Which programming language you recommend for ML? Any language, it doesn't matter. I can speak to you now in English, I can speak to you in Arabic. It doesn't matter what's the syntax I'm speaking. The important is the logic. Probably Python and R are the most commonly used. Is there a relation between web and ML? Definitely. When you shop on Amazon on the web, it is using the machine learning to give you suggestion. So everything you see is ML. Okay, I think that's it. Thank you very much. We're gonna wrap for the next session and have a great night. Bye bye.